Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So water to orange is 3-2. Ooh. We've got water here and we've got orange squash here. And we're told that we've got 80 centilitres of orange. So we've got 80 here. And we're asked to find the amount of water required. So what we do is we figure out how to get from 2 to 80. Well, we're going to times by 40. If I times that side of the ratio by 40, I've got to times the left-hand side by 40 as well. 3 times 40 is 120. So I'm going to need 120 centilitres of water. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13. Which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104. And that will give me 1,216 centimetres squared, because it's an area. I'm going to first of all work out how many parts there are in total. So we've got James with 9 parts, 6 for Andy, and 7 for Tia. So in total we've got 9 plus 6 plus 7, which is 22 parts in total. And we're asked to find a fraction Tia receives. Now Tia's the last one. So she is receiving the 7 parts. So it's 7 out of 22. To divide mixed numbers, we need to convert them to improper fractions first. And to do that, we just do the big number times by the bottom and add it to the top. So 2 times 5, which is 10, and added to the top, which will be 13 over 5. And the bottom, the denominator, stays the same. Divided by, and we're going to do 1 times 2, which is 2, add to the top, and we get 3. So it becomes 3 over 2. Then we're going to keep the first fraction, flip the second fraction, and change the sign. So it becomes 13 over 5 times, and then we're going to flip that, so it's going to be 2 over 3, times the tops would be 26, times the bottom, which would be 15. Now 26 over 15, there are 1/15s that go into 26, so that'd be a big 1, and that leaves a remainder of 11, so it'd be 11 over 15. So our answer would be 1 and 11 over 15. So in this question we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got to times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So we're going to start off with x equals 0, and we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4. 4 take away 2 is 2. Plus 10 will be 12. Now we're going to do the negative. So we're going to look at minus 1. So it's y equals minus 1 squared. And it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2. So it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus. So it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which will be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is, on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people, because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. There's 2 parts to this power. I'm just going to do it a bit bigger so we can see. We've got the negative here, and the negative will mean that we will find the reciprocal. And we've got this 3 here, which is just what the power will be. So how do we find the reciprocal? Well, if you think about the number 10, if you had to write that as a fraction, you would write it as 10 over 1. And so to find the reciprocal of it, we're just going to flip that fraction. So this will now become 1 over 10. We haven't dealt with that cube yet. So we're going to cube top and bottom with that fraction. Well, it's not going to do anything to the top, because 1 cubed is just 1. But the bottom will turn into 1,000. So it's going to be 1 over 1,000. So we're looking for the acceleration between 3 and 5 seconds. And acceleration is calculated by the change in velocity. So we're going to see how much the velocity's changed. So it started at 90 and it's gone up to 200. So that would be 110 over the time. Now the time is 2 seconds. So it's going to be 110 divided by 2, which is 55. And the units will be the meters per second, because that's kilometers, sorry, that's velocity, per second, or meters per second squared. And so it's 55 meters per second squared. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, we've got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form, because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros, and that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. This question relies on the fact that you know what the equation of a circle is. And the equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this, and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value. So 10 plus 25 is 35. Then we add the next value. So that's going to be 50. Now, the cumulative frequency is the total amount so far. So for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So we plot it at the 20. So it'd be 20 and then 10. So this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. The bottom of the fraction in the power tells us the root that we're going to do, and the top is just the power. So the top is just a normal power, but the bottom will tell us what root we're going to do. So I'm going to write out this fraction again. So 1 over 125. And I'm going to deal with that bottom first. So I'm going to leave that power of 2 on the outside. What that root is going to do is it's going to find the cube root of the numbers at the top and bottom. Now the cube root of 1 is just 1. And the cube root of 125 is 5. Now that power, the 2 on the outside, what that's going to do is it's just going to put both of them to the power of 2. So 1 squared is going to be 1, and 5 squared is 25. We're going to first of all get x equal to the 0.151151 blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000, and we'll get 151.151151 blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151151, etc. Take away 0.151151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So we would need to first of all factorise the quadratic on the right hand side, on the left hand side, and we'll end up with 2 sets of brackets equals 0. And so to do that, what we do is we multiply the coefficient of the x squared and the number on its own. And we're looking for 2 numbers that multiply together to make that number. And so 20 times negative 6 is going to be negative 120. And we're also looking for the same 2 numbers to add up to the coefficient of the x. So we need the numbers to add together to make that 7. And so just thinking about it, they both need to be opposite signs because they've multiplied together to make a negative. And they're not too different, though. They've got a difference of 7, so it's going to be minus 8 and 15, I think. And that is correct. And you can write out the factors of 120 or minus 120 and add them all together to find out which one adds together to make 7. We're going to copy out the quadratic on the left-hand side, but this time, instead of writing plus 7x, we're going to write plus 15x. Minus 8x, and I'd recommend you always put the negative first, but I'm going to show you here what happens if you don't put the negative first. So I'm going to highlight the first 2 terms because we're going to factorise those, and we're going to factorise the second 2 terms separately. So this is going to be 5x, we can divide out both of those, so that would be 4x plus 3. And the negative needs to be on the outside, so we've got a minus there, and 8 and 6 would be minus 2, so that would be 4x plus 3, because minus 2 plus 3 is minus 6. The repeating bracket is going to be our second bracket, so 4x plus 3. And the bit on the outside, 5x minus 2, will be our first bracket. So 5x take away 2 will be our first bracket. Put that into our equation. And to solve this now, we get the first bracket equal to 0. So we're going to get this equal to 0. And solve it. So get our lines down. Going to start by adding 2 to both sides. And then we're going to divide by 5. And we can show that as a fraction just by doing 2 over 5. So our first solution is 2/5. We'll do exactly the same thing to the other side. So we're going to get it equal to 0. Get our lines down. And we're going to subtract 3 both sides. So that'd be 4x equals minus 3. And we're going to divide by 4 both sides to get x equals. So x equals, that'd be negative 3 over 4. So our other solution is minus 3/4. So at the point on the graph where x is 12, it's this point here, and what you need is a ruler, and what you're going to do is rest it on so it becomes the tangent of that point. So I'm going to try my best to do it here. I'm just going to draw it out, and this is going to be my ruler, and I'm just going to move this into place. So we want that to be a tangent at x equals 12. Which is about here, and then what you do is work out what the gradient of that line is. So I'm just going to draw a line across and up, and we know that gradient is the change in y over change in x. The change in y is 2, and the change in x is 1. 2 divided by 1 is just 2. So the gradient at x equals 12 is 2. Now notice it says x equals 12. It's a curve, so the gradient's constantly changing, but an estimate of the gradient at that point is roughly 2. And you just need to make sure you rest the ruler down, and then until you're happy with it, draw the line like I've done with the blue line, and then just work out the gradient of that. And if you just show all your workings, show the examiner how you've come up with the value, even if your gradient's slightly off, you might still even be able to get full marks on some of the papers, if not 1 out of the 2 marks maybe. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.